Okay, for what we have in the case of working with Maple, okay, and I just have, again, from the examples sheet, okay, we have for the first two items, okay, we have systems of equations, and if we look at solving, and for what we have in this particular case. Okay, so in terms of looking at working with Maple, you can click on File, New, and you want to go into worksheet mode, not document mode. And since we are dealing with linear algebra, what you want to do is that to be able to fully operate with the systems and the matrices, you want to start out with an opening statement, and for the topics, you want to open with, again, starting out with alongside the arrow at the top, you want to go and enter with, and we have in parentheses. We want to type out linear with a capital L, and altogether algebra with a capital A. Algebra, not algebra. Okay, so we have with linear algebra, and then you have closing out with a colon. All right, and again, for what we had with the systems of equations, okay, we had x of 1 plus 2x of 2 is equal to 7, 3x of 1 minus 4x of 2 is equal to negative 9. And what I'm going to start out with is going with tools. And go to tutors, and we have with linear algebra, and since we're dealing with systems of equations, we'll go with linear systems solving. And since we're looking at working with matrices and putting in reduced echelon form, okay, we will go with a Gauss-Jordan elimination. Okay, and if you notice, we have a matrix up here, and for the first problem, okay, to put this first system in matrix form, okay, so we're going to have so you have two equations and two variables, and putting this in terms of the matrix, okay, so you have a 2 by 3. We have this as an augmented matrix, and just for the coefficients, so we have from the first system, we have 1x of 1, 2x of 2, and we have is equal to 7. And then we have for the next equation, we have 3x of 1. Next, we have negative 4 to represent minus 4x of 2. And we have is equal to negative 9. Okay, and putting on display, you notice here we have 1, 2, 7, 3, negative 4, negative 9, and that bar in the middle represents the equal sign. And we have, again, so we have with our system, we have x of 1 plus 2x of 2 is equal to 7. And we have 3x of 1 minus 4x of 2 is equal to negative 9. Okay, and in terms of solving, okay, we'll go ahead and close this out. And we have, again, this developed matrix set up. And you can either click all steps, but I'll just take next step, and we have the reduced echelon form over here. And once I have all the steps completed, okay, we have going with solving for the system. Okay, so the matrix has been transformed to reduced row echelon form. Okay, and we have okay, so you have in terms of converting to equations. Okay, so you have x of 1 is equal to 1 and x of 2 is equal to 3. Okay. All right. Now, in terms of what we have overall in the solution, okay, so we have, if we have these conditions, have x of 1 equal to 1, x of 2 is equal to 3. Now for the next system, okay, what we'll do here, okay, just changing the matrix and thus the system. Okay, so we have the second problem, we have 2x of 1 and minus x of 2, we have plus 3x of 3. And we'll do here, since we're looking at solving for 3 variables, okay, so we're going to make this matrix into a 3 by 4 system. Okay, so we have equal to 11. We have 3x of 1. Okay, there's no x of 2 here. We have minus 5 x of 3 is equal to negative 1, and then we have with the last portion, in case they have 1 x of 2 minus x of 3 again is equal to negative 1. So putting what we have here on display. Okay, so this is the matrix that we have built. And again, we have with our system, we have 2x of 1 minus x of 2 plus 3x of 3 is equal to 11. 3x of 1 minus 5x of 3 is equal to negative 1. And we have x of 2 minus x of 3 equal to negative 1. Okay, so after this display, if I close out and we look at solving for the matrix, now just go ahead and put down all the steps. Okay, so we had the reduced echelon form. We have 1 0 0 3 0 1 0 1 0 0 1 2, and we have for the case of solving for the system. Okay, again, this is the reduced echelon form, and we have in the equations case you have x of 1 equal to 3, x of 2 equal to 1, x of 3 equal to 2. And so we have for our solution, we have x of 1 equal to 3, x of 2 equal to 1, and x of 3 equal to 2. All right. And so just closing out. So this is just the display of what we have for the second system.